All right, welcome, ladies and gentlemen, to week number 63. My name is Mr. McLogan, and I am here to answer your questions. I forgot to do a little mic check, so I was like, let me go and check that out. So very, very happy to have you guys on again for another live stream where I come ahead and answer your questions, as well as talk to you a little bit about what is going on with me, as well as some different topics that you guys can have. So I am actually just finishing off spring break this week, had some good times, and I definitely did not do some math, which I'm going to be talking about with you guys in just a second. But yes, I am going back into the classroom again tomorrow. So some things looking forward to it, not looking forward to it. We're actually ending our last week, so we'll be getting into the last quarter, getting to there. And, obviously for those of you that are in classes, this is kind of like testing season, right? So we got a little spring break, a lot of little tests and everything going on. So hopefully if you are on your spring break, hopefully you can enjoy that. And if you have some tests coming up, it's final exams. I know some schools are wrapping those up a little bit earlier. I wish you the best of luck on that. So I do have some questions I'm going to answer tonight. These have all been pre-submitted to me, where you can go ahead and submit your questions into the description is by below. And I will actually remember to put this actually in a post. I forgot that. I was coming in a little bit late here on this one, and I forgot to pin this comment. So what I'll do here now is let me go and do this. I'll post it in there. So if you guys do have any questions that you'd like to post inside the chat, then you can definitely go ahead and put them in there. I am not going to be, however, going back to these questions during this live stream. These are going to be all questions that I've at least been able to look through, looked at them and be like, all right, yeah, these will be good for the live streams. Word problems and problems that have multiple steps I usually don't cover on the live stream. So just to kind of give you a little heads up, but yeah, that's what we're going to do. And then if you guys do have some questions inside of, or during this live stream, feel free to add them into the chat. I'm always happy to, address some additional questions as we have time, but, we do have quite a bit of math problems to do tonight. And, but that's why I wanted to kind of first talk about this is kind of weird. We're doing a lot of math problems tonight. And why are you saying stop doing math, take a break? Well, I think there's something that's very important that, I've been wrapped ahead on a lot of my students, or a lot of students like you are doing this 30-day challenge. And I think it really is important that students, if they want to get better at math, that you have to put in the practice, right? You have to keep on working at it. You have to put in the time. It's not a lot of fun a lot of the times. And it's hard to be consistent. And that's why I did that 30-day challenge. But I also think that's very important that sometimes students overlook is the rest version of learning mathematics. And, I think students are sometimes so encapsulated with, competing against other students and having to do and doing so well in math that they kind of forget to step back, relax, and enjoy the school year that at least you're having, do the best of maybe your ability, or enjoy the time that you have with family and friends, or just maybe enjoy what you're learning. A lot of times your brain needs that rest. And, I was looking back on that because one of the things that I always do, even through my spring breaks, ever since I've been a teacher, I've always worked, right? I mean, I work as a teacher, obviously, and then I'm doing YouTube videos, right? And then I'm always doing and then I'm working on my course, I'm just doing math, right? And you should feel sorry for me because I'm constantly doing math. That's how I always tell my students, you should feel sorry for me because literally if I'm not doing math or creating math, I'm grading math, right? But I think it's really important also to take those breaks. And so I had the spring break and I didn't do any work. It actually felt really good. I had to obviously do a couple things to, my YouTube channel. I had a video I was going to post and I just you know what? I'm just going to take a break. And so I'll post that video this week, and I had some math, some work that I need to get done. But I was like, you know what? I just need to give my brain a rest. And it was really good. And I think it was really beneficial. And I've done this before as well when I've, been learning, trying to learn math and you're constantly studying, that you got to give yourself those time. You got to take the breaks. You got to just stop doing it, let your brain reset and recharge. And that's why I'm a big proponent of summer break. I think it's really important as students are learning that we have these breaks given to us. And I think there's a lot of growth that comes in with students and their mind and their brain development. And when we're not constantly just trying to feed them information and constantly always competing with this learning kind of journey. And I think that's going to be the really important thing about learning mathematics is your ability to, kind of think creatively and to really have those opportunities where you're not kind of always feeling pressured of like being perfect and doing your calculations and all that kind of stuff. So yeah, that's what I kind of wanted to, kind of bring in with you guys. Let me know if you guys kind of feel the same way. If you feel like taking a break is something good, if you're on your spring break, or maybe you're taking a really long break because you are done already with the school year. I was actually just talking with somebody today that said that, they took their exams this week and then they're basically done. And I was like, whoa, I did not hear of that yet, but that is awesome if you are in that way. So, but yeah, if you're definitely enjoy, taking some breaks. And I think this is important too, I think it's also important when you're talking about like studying, because we were talking about like this, as we get into final exams, you got to start studying now, because if you think you're going to be able to cram math for like 4 hours and you're going to remember and learn everything you're going to need to for that final exam, it's just not going to happen, right? Do little chunks now, take those breaks, let your brain reset, let that information sink in. So it's really important a lot of times, just you work hard, you play hard, right? But you got to take your breaks. You got to let your brain kind of reset. So that's what I kind of want to tell you guys, because I know some of you have a lot of pressure right now, and a lot of you are really, trying to put in a lot of time on math, practicing, getting these grades up, which I totally agree. But a lot of times it might seem a little counterintuitive, but really to do better on those math tests, give yourself a break. Take a break from doing the math. Let your brain get some rest. And that's why I think it's important to start studying and start doing the practice as early as you can, so you don't feel as stressed and rushed at the end. So, yes, my eyes are doing okay. I still have a little bit of issue from my accident a couple weeks ago, which you guys can have some fun figuring that out from a couple live streams ago, where I fell off my bicycle, but that's okay. All right. How can you please make a shout out to my masters that we need a break? Yes, Quality Grape. I'll be happy to let your teacher know they give you a break, but it's always tough. It's tough as a teacher because, like we're going back to school and we got like our state exams. And so, I don't take a lot of breaks, and same thing in my classroom. But it's give and take, you got to know as a teacher how to push your students. And sometimes, I've done this as well, like where I felt like, oh, well, we're scheduled to do something. I'm like, you know what? I just feel like we're moving too fast, or we're pushing things a little too much. Like, let's take a break. Let's just reset. And, a lot of times, that's what I did actually this last week. For some of my students, as we're getting into spring break, I'm like, you know what, we took a little break. We took a little step back. I delayed the test an extra day, for the students, just because I felt like it was the most beneficial. And, but the tough thing about it is like, we still have like some final exams that I gotta abide by. Like, unfortunately I wish I could, change that, but at the current moment I can't. So I still got to kind of move forward with everything there. So, all right. Yes. That's a question, but the page is not available. Huh. Let me go and check. That's really weird. Okay. Oh. What the heck? Why is that not saying Q&A? That's so weird. That's so weird on that Discord. Oh, that's so weird. Sorry about that. Let me see if this, it works from there. I'm not sure. Well, now I have to go and check out my description and see what the heck is going on with there. Thank you so much for that. But, oh, that's because I copied in Discord. Okay. So, all right. Yeah, that's the correct thing. I was also sending in my Discord and the Discord server as well. So if you have a question that I'm not able to get to for you guys, you can also go to my Discord server as well. So, yes, thank you so much, Addie, for that. Yeah, it is the... Yeah, that's going to be the Discord. You can also go. Hey, how do you recommend studying for state exams? I think I talked about like studying a couple live streams ago. I think that right now I mean, you got to put it in practice. You got to do problems. And I think that, obviously everybody has different state exams. Everybody has like different, classes and courses that you're taking. But I think the earlier that you can start, the better. The more practice problems you can do, whatever your teacher is giving you, like do them. I think you should start reviewing all of your old stuff that you've already learned up to this point now. And yeah, start looking at, start reviewing now. Don't wait until the very, very end. Do as practice problems as you possibly can. And then also I think of like creating a cheat sheet, and putting down all those extra examples for you on as well. I think would definitely be helped out. Well, hey, Da Monkey and Ezekiel, good to see you. Actually was through Nightbot. I'm not sure. Answering for question number 1 on video. I'm not sure what you are. Oh, it is x equals 3, but since, I think you're already answering the first question. Ooh, all right. How do you think revising is good? I'm not sure. X equals -3. I gotcha. Very good. All right, guys. Well, if you, just a reminder, I think we have quite a bit. I thought I did this question before. I'm looking back at my last week's questions and I don't see it though. And it's really bothering me because I do remember doing a problem that was very similar to that, but it's not. Oh, it is. It is right there. It was, oh no, it was very similar. That one was equal to 1. All right. So, somebody asked me that 2x minus 4, very similar. No, it is the same question. Yeah, I already did this question. All right, so they posted in their thing. So we're not going to do that. All right, guys, cool. You know what that means? That means we have an open question. So if you have a question you'd like me to start off with, I am more than happy to kind of go for that. So we do have a whole bunch of other questions I'm going to address. But if you do have something that's like kind of relatively easy to type in and you want to ask, I will start off this live stream with actually a open question in the chat, as long as you don't try to deceive me and make it too hard. I only pick the easy ones. No, I'm just joking. But yeah, I'll be more than happy to kind of take any other questions or maybe address anything else that maybe you guys have. It doesn't have to be a math problem per se, but it could be definitely on anything else that you have maybe a question on from in there. Got a 63. Well, good job, ZP. All right. Why does it look so much to you? Because I was riding my bicycle and I fell off my handlebars and my face went to the pavement. And if you think I look bad now, you should have seen me on my live streams like 3 weeks ago, or I think 2 weeks ago. Go ahead and check it out after this. You'll see my face is pretty big bruise because it happened on Saturday morning. And then so Sunday night when I do my live streams, it was, I was looking pretty good. It was pretty swollen and everything like that. My eye didn't get swollen shut though. Everything is also pretty good. My neck is still a little sore, but all right, I got one. Hayden, you already sent in your question and I will be getting to that one last. Not because you just said that, but because I already saw it, because I already have yours scheduled in here. So I will do one from Jay, which is 2 square root of, wait, no. All right. So I believe that's the square root of 3. And then that's times the secant of x plus 4 equals 0. Right? I believe that's, oh, no, it is 2 square root. Okay, yeah, you're ahead of that. Okay, so you had 2 square root of secant of x equals 4. All right, you didn't, I will just say solve all the solutions. And then, yes, Hayden, I will get to yours. You are, I already have yours written down. That's why I was saying I wasn't joking with you. You're purposely going to be last, but I have you right there. So thank you for submitting that in. All right, we've got quite a bit of questions. So let's go ahead and, yes, let's go ahead and get to some math questions. And again, guys, if I do have some time at the end, then I'll be more than happy to answer any other questions that you guys have in from there. All right, so question number 1 comes in from Jay, and basically we need to solve for secant of x. So the first thing we're going to want to do in this case is we're going to want to, this doesn't seem right though. No, okay, that would, okay. First thing we're going to do is solve for or isolate the secant of x, our trigonometric function. So we're going to do that, but just by using our inverse operations. So 2 square root of 3 secant of x equals -4. Divide by 2, divide by 2, then square root of 3 equals a secant of x equals -2. Divide by 3, divide by square root of 3. Okay, so I have the secant of x is equal to a -2 square root of 3, right? Now, you might say, well, why don't we rationalize the denominator and blah, blah, blah. But remember, if the secant is, or actually, let's go through this. Crap. Remember, if the cosine of x is like opposite over hypotenuse, right? Then the secant of x, remember, is the hypotenuse. That's not cosine, that's not opposite. I know, don't need to tell me in the chat. I'm sorry. That's adjacent, right? Nobody got it? Did I beat anybody? Okay, maybe some people might have got me. So it's adjacent over hypotenuse. So the secant is going to be hypotenuse over adjacent, all right? So they're just reciprocals of each other. So what that means is I can rewrite this. Sorry, I'm going to go horizontal. But hold on with any other questions, guys. I'll be able to address any other questions at the end. I have a lot of questions I got to get to. So hold your questions, and then we'll see what time we have at the end. So therefore, this is cosine of x is equal to a negative square root of 3 over 2, right? Because it's just the reciprocal, kind of same idea that we have going on here. So now I got to understand, well, when is cosine of x equal to negative square root of 3 over 2? Well, that's going to be this angle as well as that angle, right? Because cosine is the x coordinate, it's going to be negative over here. And let's see, using the unit circle here, what angles is that? Well, you can say x is going to equal, that's a what, 5 pi over 6, and then x equals a 7 pi over 6. And then if I'm going to find all the solutions, then I can say plus 2 pi n, plus 2 pi m. Because if you keep on adding 2 pi, right? Here's this one angle. If you add 2 pi, it's going to take you to that same angle again, the same terminal side. If you add 2 pi again, that'll take you again there. So you have to, if you have these angles, you keep on adding 2 pi, that's what we do, creates what we call coterminal angles, which is going to be another question that I'm going to address up here. So, so that's what so when you're trying to find all the solutions, you can always add 2 pi. And then there's ways we can simplify them from each of those solutions. Okay. Thanks, Dave. All right. Find the approximate value for each of the angle. So for this one, we're going to want to use our calculator. And, kind of coming up to here, like, I kind of like how some of you guys, how some of the questions naturally actually work with each other here. So in this case, if I need to, over here, we're trying to find the angle, right? We're trying to find the angle that satisfies this equation. Now here, we're not trying to find the angle that satisfies the equation. We're basically trying to find the angle that's, the sine of what angle equals 0.7245. So we need to find one answer, okay? So we're looking for one solution. However, if we need to undo what's sine, how do we do that, right? We know how to undo addition by subtraction. We know how to undo multiplication by division, right? So how do we undo sine? Well, that comes into what we call our inverse operations, right? You can take the sine inverse of both sides. 0.7245. Now, it's very important though that the inverse function of sine is the inverse operation of sine is a function. So what that means is there's only one answer. So the sine inverse has a restriction for our sine function of angles only. The angles for sine is only going to be between the pi halves and negative pi halves. Okay, and that's for the sine of x and cosine of x. And tangent of x. And then for cosine of x, it's between 0 and 2 pi. 0 and pi. Okay, so that means they're restricted. And again, the reason why we have that is because if we didn't, we would have multiple solutions, which is fine if you're trying to solve an equation. But when you're trying to type something into a calculator, right, if it's a function, there can only be one answer. So what we have here is S equals the sine inverse of 0.7245, right? We can only have one answer. Now this answer is going to be between pi halves and negative pi halves. Then again, you could find the answer in degrees or in radians. Typically when I'm doing the sine inverse, I'm going to use degrees, which my calculator is already in. So all you simply do is just do sine inverse of 0.7245. And you get equals 46. It says round to the nearest whole, so it would be 46 degrees. And you basically just do that same thing. You're just going to use the sine inverse or the cosine inverse of those decimals, and you just plug it into your calculator. All right, question number 3 is complete each diamond problem. So basically, this is a way to kind of help you prepare you for your factoring. So what it's saying is you have two numbers. You're given two numbers, right? This number 12 and this number 7. So what they're saying is find two other numbers that multiply to give me up here, right? So a lot of times the way that I write it is, so we're trying to find two numbers that multiply to give me 12, but add to give me 7. So you can just list out like all the numbers that multiply to give you 12, right? Forget about the positive or negatives for a second. Just do 12, 1. You could do 6 and 2. You could do 4 and 3. And then just look at which ones add up and you say, oh, 7. Well, it has to be positive 7, right? So therefore, it's going to be a positive 4 and a positive 3. Now, the next one is helpful because you're multiplying to give you a negative. Well, what that means is one of the numbers in your product has to be negative, right? If you're multiplying two numbers to give you a negative, one of them has to be a negative. So what that means is if one of the numbers is negative, when you add two numbers, right, and one of them is negative, you're technically like finding the difference. So when this number is negative, what we're going to do is I'm going to find the numbers that multiply to give me 14, but instead of finding instead of adding them together to give me 7, I'm going to say which ones would have a difference of 5. Now, don't worry about the positive or negative for a second. Just figure out which ones have a difference of 5. So we do 14 and 1, 7 and 2. And you're like, okay, obviously here this has a difference, right? Now, if the difference is a positive 5, that means the 7 needs to be positive and the 2 needs to be negative. So that's a positive 7 and a negative 2. And there you go. All right, question number 4 was doing geometry. We're actually going back into circles next week for myself. So I think if I remember this correctly, when we have these inscribed arcs here, if that's 84 degrees, then that means that angle is 84 degrees. So this was ACB. So I believe that's going to be 84 degrees, if I remember correctly. And then the same thing. So when you have that inscribed angle, like on here, because it's different when you have a central angle, that's going to be, the central angle is going to be double that angle, right? But if it's on the other, if you have an inscribed angle on the part of a circle, then that's going to be the same measure. That looks, doesn't really look that great, that 84 degrees. So I'm not sure. That B, C to D. So then this one would be 60 degrees, if I remember correctly. And then ACD. So ACD, well, that's just going to be the sum of those two. That doesn't look right. Because that'd be 140. That'd be, dang it. I don't remember my geometry. I'm going to have to go back to this. I should have looked at this one before I did it. Figure FE is tangent to the circle. MA is 84, CA is 60, and CD, that's going to be 120. And yeah, they're going to add up to 360. ACB. I'm pretty sure, I could have swore that inscribed angle. Unless somebody else is telling me different, then you can let me know. Then I'll go from there. I mean, I guess you don't have to go off of, you know what, I'm just going to go off of my memory, and somebody can always add into the correct in the comments. I believe that is 84 degrees. Although these would be all the same though. So, I mean, I guess that one would be 60 degrees, right? I'll go back and check it. And if I need to verify this or fix it, then I'll go back to it. So then ACD would be 144 degrees. Because that's your inscribed angle theorem, if I remember correctly. right? If that's x, then that was going to be x, right? And then that would be 2x if that's your central angle, if I remember correctly. So I'll have to go back. I thought I did, but now I'm second guessing myself. So I apologize for that. That's why I like to not do problems that I am not 100% confident on, because then I'll second guess myself when I start teaching or going live, and then I look like an idiot. But that's okay. I'll fix it if I made a mistake, and I do apologize. All right, so question number 16. Simplify the following expressions with exponents. Okay, so typically on this one, what I'd like to do here is let's just go ahead and multiply our numerator, and then what we'll do is we will get rid of the negatives. All right, so typically a lot of times I like to eliminate my negatives from the get-go, but in this case, you know, I'd like to kind of multiply here. So 3 times 6 is going to equal 18. X to 2 times x to the negative 3. Remember, we're just adding our exponents, right? So you're just adding the powers. So 2 plus negative 3, so that's a 2 plus a negative 3. And then this would be a y to the first, right? Because that's a y to the first, plus 4. Okay, and we're not going to do anything in the denominator, at least right now. All right, so then I end up getting a 18x to the negative first, and this is going to be a y to the fifth, all over negative 9x to the negative fifth, y to the negative third. Okay, so now we have basically division going on. And again, remember, like for division, you just like you're subtracting the powers. You could also rewrite this if you didn't want to do it that way. But in this case, like we have 8 divided by negative 9, so that's going to be negative 2. And they have x to the negative first minus a negative 5. Okay, so notice my parentheses. And then I have y to the fifth minus a negative 3. Okay, so just make sure you notice my use of parentheses here to get that correct answer. So I have a negative 2. So minus the negative, that's going to turn to a positive 5. So that's going to be x to the fourth. And this would be y to the eighth. All right, question number 21. I wasn't going to do this one. I was going to set this one up because I'm not sure. Show that the value of the center. I'm assuming O of P is 9, and I'm not really set up with that. So I wanted to kind of set you up with and just kind of know like, well, if I have 2 points, right, and I have the length, I could use the distance formula, right? If I have x and y, okay, and then I have another point, so we could call this like x1 and y1. Then I could call this x2 and y2, right? And then if I had the distance or the length would be 10 units, well, I was like, I can use the distance formula, right? I can say, remember, d is equal to the square root of x2 minus x1 quantity squared plus y2 minus y1 quantity squared. So therefore, I have 10 equals square root, and then you could say 4 minus negative 2. Again, notice the use of my parentheses, squared, plus y2, which is going to be p, minus 1 quantity squared. Now again, so to solve this, you're just going to use your inverse operations here, right? So you're going to square both sides. So therefore, when you square both sides here, you get 100. And then 4 minus a negative 2, that's going to be a 6 squared. So that's going to be a 36 plus a p minus 1 quantity squared. Subtract a 36, subtract 36, that's going to be a 64 equals a p minus 1 quantity squared. And, then you can go ahead and take the square root here, square root. And when you take the square root, you're going to get 8 equals p minus 1, and then add 1, and you get 9 equals p. I guess I will do the problem. And then find the equation of AB. So to find the equation, now you're basically just going to find now you can just plug in, now you already have this 1 point. You can say that p is equal to 9, so that's now equal to 9. Now we just need to basically figure out the slope, right? So you could say, all right, slope is going to be y2 minus y1 all over x2 minus x1, right? So we have 9 minus 1 all over 4 minus a negative 2. So 4 minus negative 2, that's going to be a 6, and that's going to be a 4/3. Okay, so now basically you can just pick one of these points. Let's just take this point and then our slope 4/3. So I can say y minus, so now we're going to use the point slope form. So y minus y1 equals m times x minus x1. So y1 is going to be 1 equals a 4/3 times x minus x1, and that would be a -2. There you go. And hopefully you can go ahead and distribute and simplify a little bit further, but that is in your standard form, so you can, typically that will be good for you guys on this. All right. Question number 7 is, please explain how to memorize square roots of 2 and 3 unit circles, and what are the terminal angles? All right, so I believe you mean coterminal angles, and that's what I was talking about. So coterminal angles are just two angles that have the same initial and terminal side. So whenever you have an angle like this, any angle that you can add 2 pi to or subtract 2 pi are going to be coterminal, okay? So, so how do you memorize? The way that I like to memorize it, which I know, is very like popular, many videos on like the hand trick, right? Everybody has like this, memorize the unit circle using the hand trick and blah, blah, blah. And like, yeah, it's cool. But I think it's like just kind of, you have to, if you're going with the unit circle, you have to know the first quadrant. All right. And I think it's very easy to remember, at least on the first quadrant, everything is being divided by 2. So the denominator for all of these are being divided by 2. Okay. All of them are being divided by 2. And then if you can just remember on the top here is you just start in the top left, square root of 1, square root of 2, square root of 3, then square root of 1, square root of 2, square root of 3. And just kind of follow that pattern. And then again, you still need to remember the angles though, right? This is going to be 30 degrees. This one is 45 degrees or pi over 4. And then this one is 60 degrees or pi over 3. So you still got to know your angles. And again, you still got to be able to reflect this to the other angles there. The problem with finding like the coterminal angle for 540 degrees is there's infinite many angles for 540 degrees, right? All you got to do is add and subtract 360. So if you take 540, add 360 degrees, that would be 900. That is one coterminal angle, right? Because you can add or subtract 360 as many times as you want to get that answer. All right. Question number 8. What is your advice for aspiring math teachers? I go to St. Johns County. Well, welcome to my live stream. Thank you so much. And I think I had your name and I forgot that, so I do apologize for that. And I work in St. Johns County, taught down here. Well, I very appreciate that. And advice for aspiring math teachers. I think one thing you got to understand is the education and math landscape is changing. I think our use of technology and instruction is, it's going to be constantly being redefined. And one thing that, I've been using, when I first started, teaching, I was using like the protractor, like with the, not the protractors, but it was the board where I had like plastic sheets on the thing and I'd write on them and doing my math problems. And now I'm using, Desmos, and students are on their phones and they're submitting answers and like crazy kind of stuff like that. And I think that's you want to kind of, just kind of know like maybe the way that you have taught, because things are moving so quickly now. I think just don't get held up or stuck up on the way that you learned math, because I think one of the best pieces of advice that I can remember hearing was, most people, and this is something I kind of took to heart as being a teacher, is that, most people that are teachers because they were good at school, right? Most people are good at math. If you want to become a math teacher, not many students are bad math people, are bad at math that become math teachers, right? Not many people have that idea or that understanding of struggling. So you gotta kind of you gotta understand things that people don't look at the math problems the same way that you did, right? And maybe some of the ways that made you successful in school is not how other people were brought up or ever taught or learned. So you got to have that understanding and that ability to be able to relate to many different students. And so I would say that would be a great piece of advice for you to hold on to is just, kind of remember that people approach problems and their situation and their life completely different than the way that you might have seen things. And then also know that, things are changing and to always kind of look to that future, don't look to just like, oh, well, this is how I did it in school or when I was growing up. Like, look into what's going to be the next thing. How can I prepare for what education is going to look like in the next couple of years? Like, how can I utilize technology inside my classroom with my teaching to become a better teacher? And that's what I would recommend for you. So best of luck. Teaching is a wonderful endeavor, though. All right, let's continue on. So question number 9, I don't know why, thank you, Brianna, for submitting these. I'm not sure why I decided to do these, or at least 2 of them. But let's go there. I think they're just because they're so different. This is from elimination. So the first thing I would do here on this question is, let me see. Let's maybe explain them up because I want to do some of my math here. So the first thing I recognize here is that I'm going to want to use eliminate. Like we're going to have to use 2 different multipliers. So I'm going to, since the one's positive, one's negative, I'm going to eliminate my y variable because it's really easy for me just to find the LCD between 2 and 3, which is 6, right? So on the top, I'll multiply everything by 3. And on the bottom, I'm going to multiply everything by 2. So when I do that, what I get is a 9x plus 6y equals a negative 27. Just make sure you distribute. That's like one of the biggest mistakes students make. And then over here, you get a 10x minus 6y equals 8. Okay, so now when you go ahead and add these, and those are not very nice. Wow. So that's going to be 19x, I'm sorry, equals a negative 21. And yeah, then you just go ahead and solve, I guess. I mean, geez, not going to be very nice answers, I guess. So x equals a negative 21 over 19, unless I made a mistake, but I'm not seeing anything that I did. That's going to equal 10. And you want to do 3 and 2. Everything's aligned. Wow. Just, Okay, well, yeah. And then once you get that answer, you're just going to plug that back in. So unless anybody else lets me know that I made something, made a mistake, feel free to add it in the chat. But then you just go ahead and take that x and you just multiply back in. And I don't want to go ahead and do some decimal answers for this one. So, but you could just go ahead and use a calculator to go ahead and solve for y. Let's go and take a look at this next one, because this next one, I'm going to approach this a little bit differently here. For this next one, I recognize that first thing that I would do is I would just get rid of my fractions. Okay, so in this case, I would say, well, I can multiply the top equation by 4, and I can multiply the bottom equation by 2. So you know what? I'm just going to multiply by these scalars first, just to get rid of fractions. Okay, now you could easily do them with fractions, but if you're like most students that I teach, I know fractions just scares everything out of them. So I just say, you know what? Why don't we just get rid of our fractions? So I'm going to multiply by my denominators here, plus y equals 0. And now I can say, all right, now I just got to eliminate my y. 27 plus 8 is a negative 19. It is. Thank you. I am an idiot. Thank you so much. I love you, Professor Wizard. Yes, that's a negative 19. I was like, man, that doesn't make sense. Why would that be? You just can't do simple math. All right, so therefore you get x equals negative 1. And I'm like, no, how would that work on that one? I must have made a mistake. So then you just plug in negative 1 minus 3y equals 4. And I didn't actually double check my work there. I was checking all the other math and I didn't check my work there. So then you add a 5. So then you have negative 3y is equal to 9, divide by 3, divide by 3. And again, technically what you should do in that case, if you do, and if it wasn't a live stream, I probably would approach this a little differently. But if you do get something stuck, you're like, because that's not very common, especially on a worksheet like this, where you're just constantly practicing, elimination problems. I'd probably maybe like try eliminating another one, right? If you can't figure out the answer, which I didn't want to dive too deep on this one, because obviously that's the great thing about live stream is that people will just can help me out and see my answer of my blind spot. But if I was working this out, I'd just maybe try it a different way and just go back to the problem, because typically, unless you are expecting to have like some really odd answers with the calculator, you're going to have a worksheet that's going to be fairly nice answers, as we like to sometimes say. All right, the good thing about this one, as long as I distribute here correctly, yeah, because I was only checking my distribute, I didn't check my adding, which, geez, embarrassing. All right, but looks like everything here I did correctly. So now I still need to use a multiplier, right? But now I'm going to just multiply by a positive 3. So therefore I have an 8x minus 3y equals a negative 28. Because again, I want to get rid of the y's again, because that's the easiest to get rid of. You could multiply by 4, actually get rid of the 8, but then you have to make it negative, and it's just a little bit of work. All right, so in this case, now let's go ahead and add them up. So I get a 14x, that goes to 0, equals negative 28, divide by 14, divide by 14, x equals a negative 2. And then now I can plug that negative 2 in for x over here. You could really plug it in for anything, or either equation. But let's add a 2. So you have 2 equals a 1/2 y. I'll just put it on the other side. Positive 2. And then you'd multiply by 2 on both sides. And y equals 4. And voila. Okay. All right. So the next one, can you explain the difference in coterminal and reference angles? Yes. So again, the coterminal angle is an angle that has the same initial and terminal side. Okay. And a reference angle is the positive acute angle. So it's positive and acute. Okay, so it's the positive acute angle, let's call this alpha prime, between the terminal side and the x-axis. So if this is theta, alpha, then your reference angle is going to be right here. So it's between your terminal side and your x-axis. So it's always acute. That means it's less than 9 degrees, but larger than 0. And it's always positive, okay? So there's no direction to it. Whereas when we're drawing angles in standard form, we have this is the positive direction, this is the negative direction. So if it's the reference angle, it's just the positive acute angle, and that's it. The next one is, and then so the coterminal angles, all you simply need to do for a coterminal is just add and subtract 360 degrees. Now, this student was saying, how do you have to add, what about 48 radians? Well, all right, that's a little different. So if we're going to look at 360 degrees, let's go ahead and find 48 radians, which, dang, that seems crazy. So, all right, all the way around the circle is 2 pi, which is approximately 6.28 radians, right? So if we go around, that's 6.28. Right? If we go around again, that's going to be 12.56, right? So how many times around can we go before we can't go around anymore to get to 48 radians? So what I'll do is I'm going to do 48 divided by 2 pi. Okay, so what I did is 48 divided by 2 pi. And what I get is here a 7.639. Okay, so that means it can go in 7 times. So what I'll do is I'll do 7 times 2 pi. So that means that's going to be my rotations. And let's see what that is. 2 pi. That's going to be 43.98. So let's do 43.98. All right. And I'm working with approximations. So I'll do 48 minus 43. Oh, that's a 98. So 48 minus 43.98. Oops. Oh, I was supposed to do the whole answer. All right, so 48 minus that answer. And what I get is a 4.01. Okay. So that equals 4.01. So what that means is I can go around this circle 7 times. All right, so I'm actually going to do this here just because I want to. Okay, so we're going to go around 1, 2, 3, 4, 5, 6, and then it goes around 7, right? Because 7.63. So this is my 7th. And then after the 7 rotations, right? That's 7 pi, or I'm sorry, that's not 7 pi. That's 7 rotations. Then I'm going to go 4.01. Well, hopefully you recognize 4.01, like pi, right, is halfway around circle. That's 3.14. So 4.1 is going to be like somewhere right around here, somewhere, right? Not sure where it is. So if I want to find this reference angle, all I'm simply going to do is I'm going to take pi. I'm sorry. I'm going to take that answer. I'm going to subtract it from pi. And so if this is alpha, then my reference angle here is going to be a 0.876. All right. And if I want to find coterminal angles for 48 radians, just add and subtract 2 pi. Right? You can just take that angle and just keep on adding and subtracting 2 pi. There's infinite many answers there. Is it pi? No, it's not pi day today, is it? Oh, it is happy pi day today. Oh my God. Well, I don't even care for a pi day anymore. So that's okay. I don't do anything special inside of my classes anyway. So that, but I guess I could have definitely tied away a different live stream for Pi Day. That's kind of crazy. Sad on me. All right, let's go and talk about question number 11. Given the table below, determine whether y is a function of x, and then if the function is 1-to-1. Okay, so if y is going to be a function of x, that means for every x, there's only going to be one output for y. All right. So we look at all of our inputs; they directly correspond to one output, right? So -1 only goes to 2, right? -1 doesn't go to 2, and then -1 goes to 7, right? For every input, it goes exactly to one output. That's good. So it is a function. Then we want to determine if it's 1-to-1. So what 1-to-1 states is that also works backwards the other way. Every y is going to uniquely map to only one x, which again, like, so if -1 only goes to 2, then 2 should only go to -1, right? 2 should not also go to like 0 or something like that, which is also the case. So that is also 1-to-1. So 1-to-1 is kind of like that, it's a function both ways. All right, next one is dividing fractions. So the student was asking, they want to know, this is from Ahmed, want to know about how to involve or solving as far as on these fractions, which crap, I'm running a little bit of time. So the main thing, the way I like to look at fractions is like, let's talk about a fraction. Let's talk about how to get rid of fractions. So like 8 divided by 4, I can get rid of that, right? Because I can divide the 4 into the 8, right? So that becomes a 2. Now, another way we can get rid of this fraction is, or another, like you could say, so therefore you can get rid of fractions by dividing, right? Well, what about if I had like 8 divided by 8? Now 8 divided by 8, I can get rid of that. Like you can see, like something divided by itself is 1, right? So the purpose is, if I had a fraction like 7/1, I don't really need to divide 1 into 7. Like it obviously is always going to equal 7. So the point that I want to kind of bring to you is, if you want to get rid of a fraction, if you want to get rid of something in the denominator, you can easily just divide it into it if it's possible. The other thing is to get your denominator equal to 1, because if your denominator is equal to 1, then you're just going to have your numerator. So one of the better ways to look at this is 3/7 divided by 2/3. Right? Now, again, I don't really know how to divide fractions. Like that's conceptually, that's kind of a pretty confusing concept to think about, right? However, the way that I like to kind of think about this is saying, well, I don't want to divide by this fraction. I'd rather not divide by a fraction. So what I want to do is I want to get this to equal 1. So if I can get this to equal 1, then I can just keep my numerator, right? Whatever my numerator may be. So if I think about it, if I have a negative 2/3, like if I have 2/3, if I have a fraction, how do I get that to be 1? And hopefully you recognize you just multiply by the reciprocal. Now, whatever you do in your fraction, whatever you do in the denominator, you have to do in the numerator, right? Because if I have, if I had 8/4, right? As long as you multiply by 2 on the top and the bottom, that gives you a 16/8. So that's still the same fraction, right? It's still 1/2. So when you multiply 3/2 on the top and bottom, this becomes 1, and therefore you get a 9/14 over 1, which is just a 9/14. Now, many students, once they get the hand of this, they just say, oh, well, you just flip and reciprocate, right? And yeah, that is, or flip and multiply. And yes, that's exactly what we are doing. But the reason why we're doing it is because of this, right? So make sure you understand this before you just go into the flip and multiply idea. But that is also works, which is 40 divided by 9. All right, solve the equation after rewriting the form. So the student sent multiple questions, which I never do multiple questions for. But I decided, I don't know, I'd work through a couple of these because, again, the main thing is just setting everything, getting it to the same side. Yes, because Hayden, I did do that. The reason why I'm not doing that is because I've been teaching math for many, 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 many years. And what happens is students just memorize flip and multiplying, and then they forget it, right? Because it's very easy to like do it as a trick and then just to totally forget it. So, but I did show it to you. I mean, I showed you here, like, yeah, it's the easiest, fastest thing to do. Like, the problem is many students have no idea why or how that's happening. And then what happens is as they go into more advanced mathematics, they're lost upon this idea of this dividing fractions and what it really means. So I just like to, obviously as a teacher, I like to provide a little bit more of a context rather than just giving people just the tricks in the trade, just because I've seen what a lot of students, they rely on the tricks, which is great. I'm not against them. I teach them as well. But a lot of times they can hurt students as well if they don't have any conceptual understanding of what they're doing. Now, if it's just for a test, that's a different understanding. That's a different question, right? But yeah. All right. So the student sent a lot of them, all the same questions, were all the same thing. Like, just get it equal to 0. So the first thing I'd want to do here is add the 3. Here, I'm going to add the x squared and then subtract the 1. And I think for the first problem, it was factorable. So that's why I was like, oh, okay, I'll do it. And then the second problem was non-factorable. So therefore I had to use the quadratic formula. So that's why I was like, okay, I'll just go ahead and do that. That looks good. So negative x, so that's a positive x squared plus 8x minus 1. Okay, so for here, you always want to check for factoring first. All right, and if this is factorable, then the product of these two is 2w plus w is going to give you 2w squared, which does work. And then I can basically figure out what two numbers multiply to give you 3. Okay. Well, again, we have 3 and 1. All right. So we're good. Now, since this is positive, that means both my factors either positive 3 or negative 3 positive 3, positive 1, or negative 3, negative 1. Since my middle term is positive, we're going to be dealing with positive. So I just need to be able to determine, well, should I put the 3 here or should I put it here, right? Well, again, your inner and your outer, when you have a quadratic where a is not equal to 1, these two products need to add to give you a 4. So I don't want to multiply a 3 times 2 because that would give me 6, which is already larger than 4. So that's why I'm going to put my 3 here and put my 1 here, and you can see that that does work. So now I can use my zero product property. Plus 3 equals 0. W plus 1 equals 0. So W equals a negative 3/2, and W equals a negative 1. And voila, there we go. All right, question number 2. That is not going to be factorable because I know there's no two numbers that are going to multiply to give you negative 1 that are going to add to give you an 8. And hello, Jake Yoon, how are you? So I'm going to immediately go to the quadratic formula. So quadratic formula, ax squared plus bx plus c. So that's going to be x equals opposite of b plus or minus the square root of b squared minus 4 times a times c all over 2 times a. So it's going to be negative 8 plus or minus, let's see, b squared. So that's going to be an 8 squared minus 4 times a times c. Oops, be careful with your parentheses. All over 2 times a. All right, so let's see what we get here. Let's try to simplify this. So it's a negative 1 plus or minus. Let's see, that's going to be a 64. Now this is going to make me a positive. So it's going to be a plus 4 divided by 2. And what would the direction say? Answers in simplest radical form. Of course they want it in simplified form. So that's be what? 68 divided by 2. All right. So Now I got to see 4 would go into there. That would be 37 times. I'm going to check. I'm going to use my calculator. No, it wouldn't be 37 times. 68 divided by 4, 17 times. Right, yeah, okay, 17. All right, so then I can simplify this to negative 8 plus or minus. I can take the square root of 4, so that would be a 2. Square root of 17 all over 2, and then you can simplify that one more time. What I get my other answer is a negative 4 plus or minus the square root of 17. So you can divide that 2 into both of them. Yes, Jake, and there is a way that you can request a problem. If you look in the pinned messages, that's where you can submit your questions. But I will not be going over any more questions in this live stream. Unfortunately, I had quite a bit of requests, but I do have a Discord channel where you can also post your questions and get help as well, which has been very beneficial for many students. I'd highly recommend you check that out if you don't want to wait till my next live stream, which is next Sunday at 9 p.m. All right, this next student was asking just how to multiply this, and the student was kind of getting, I think, confused on what to do with the variables. And so, again, variables, you can only multiply with terms. So, numbers, you multiply with numbers, and variables, you multiply with variables, but only when they're like terms. So you can just rewrite this as a 3 times 15, times y times x. There's nothing I can do with the x and the y. They're not like terms. So 3 times 15 is going to be a 45, and then I'll just write this as xy instead of yx. All right, question number 17 said the area of a triangle-shaped wall. The base of the wall is, how tall is the wall? Oh, I didn't read this question when I was looking at it. Okay, so the area, so it's a triangular shape. So area equals 1/2 base times height, right? So if the area is 12x squared plus 13x minus 14, that equals 1/2 the base, 4x plus 7 times height. So we just need to find height, right? So let's go, you could distribute that, right? But then you're going to have a fraction. Nobody wants a fraction, right? Nobody wants a fraction. So what I would say let's do is let's multiply by 2 on both sides. Therefore, I'll have a 24x squared plus a 26x minus 28 equals a 4x plus 7. Okay, so now I can go ahead and use some division. Now, we can go ahead and use long division here. So you could use synthetic division, but then again, you're going to be dealing with fractions, and who really wants to be doing that? So let's have a 24x squared plus a 26x minus 28. All right, let's see what happens. So 4x goes into 24x squared. That's going to be a 6x times, right? So you always divide the first term of your divisor into first term of your quotient. So 6x times 4x is going to be a 24x squared, 6x times 7. 6 times 7 is going to be a 42x. Okay, and then we will subtract our rows. So that's going to go to 0. And then here, that's going to go to 16. I'm already losing my brain. So that would be a negative 16. Right? Yes. Okay, negative 16x minus 28. So you can bring down the 28. All right, 4x goes into a negative 16x. That's going to be a negative 4 times. Negative 4 times 4x is going to be negative 16x. Negative 4 times 7 is going to be a negative 28. And there you go. As you subtract, that'd be your base. So there's your base. Well, thank you, the food, Jazzy. I appreciate that. This next question, the student, I think they recreated the problem, and they were talking about similar triangles or congruent triangles. And I'm not sure if I understand the question correctly enough to understand the angles of measure. So I'm just going to use basically what I noticed that I'm assuming this is a right triangle. And so therefore I can use some supplementary angles here. If this is 144 degrees, well, then I know that, let's call this, no, I don't want to call this X. Let's call this Y. Well, then I know then Y plus 144 equals 180 degrees, right? So let's subtract 144. And Y is going to equal a 36 degrees, right? Okay. Well, then what else? What do we know about Z? Well, we know that if that's 90 degrees, we know that 90 degrees plus 36 degrees plus z is equal to 180 degrees as well, right? Because all the angles in a triangle add up to 180. So therefore, this is 126 degrees plus z equals 180 degrees. So subtract 126, subtract 126. Z is going to equal a 54 degrees. All right. Now, again, we're still not done. All right. So again, we have another line here. So we know that z plus x, or I'm sorry, not z. We already know what z is. 54 degrees plus x equals 180. So now we'll just subtract a 54 and x equals 26 degrees. All right, Hayden, we're on your last question. Sorry for making you have to wait an hour to get to this, but maybe you're watching the replay or not, which all my replays, guys, or all these questions are available on the replays with timestamps if you are interested in always catching back in different problem. All right, so next question here. So when we're solving, kind of like what we were doing at the beginning when I was doing those fraction problems, I don't want a squared to be in the denominator. So what I'm going to do is whenever you're solving, I want to get rid of this in the denominator. So I'm going to multiply by my LCD. So my LCD in this case is going to be a 6a squared. That is the smallest term that all of them go ahead and divide into. Yeah, it's 120. No. Yeah, 126. Thank you. Thank you, Andrew. All right, so my LCD is a 6a squared. So what that means is I'm going to multiply everything times that. Oops. Equals. Okay, I'm going to multiply that by everything. So what happens over here is, actually, let's just rewrite. I got time, right? I mean, you waited this whole time, or maybe you did. Yay, Hayden, you're in. All right, cool. So that's going to look like this, 6a squared times a 1 over 3a squared. A lot of times I don't go through all of this work, but because again, there's other shortcuts you can do here, right? But since you called me out on my shortcuts before, I'll work this one out. So therefore, there's my distributive. Okay, now let's divide things out. The a squareds divide out. 6 divided by 3 is 2. Here, my a divides an a squared 8 times, right? So that's going to be 6 minus a. And then here, the 6a squared and the 6a squared divide out, so that's leaving me with the 1. So now we just need to solve for a, right? So let's subtract the 2. Negative 6a equals negative 1. Divide by negative 6, divide by negative 6. A is equal to a positive 1/6. And voila. Yes. So sometimes I do take any other questions over here, but it is late and I've just finished off my spring break and I got to go to school tomorrow, guys. So thank you so much for joining the live stream. I will be again back next week on Sunday to answer your questions. So please feel free, guys, if you have questions, go ahead and submit them into the in the link that is pinned of this chat. You can submit them at any time throughout the week and I will answer them next week, or at least as many answers or questions as I can get to. But if you do not want to wait that long, or you have other questions, or you want to help other people with their questions, then please go ahead and check out the Discord server, which is the link is also in the description. I hope you guys have a great break. I hope you guys have a great week. I hope if you have the opportunity to take a break from math and instruction and learning and everything, you can enjoy that rest and relaxation and get ready. It is the end of the year, is like that sprint mentality. So, take advantage of enjoying yourself and giving your brain a little bit of rest. Okay, so hopefully you guys can take that to heart and apply it. Otherwise, I wish you guys the best of luck on your exams, which I know are starting for some of you. So go ahead and study hard, work hard, and do the best. And I'll see you guys next week. Cheers.